Good morning, students. So today I will be discussing, as you are going to see on the screen, definition of automation and automated system. What are the different elements of an automated system? Okay, and levels of automation. So as we have discussed in the previous sessions, that the different way in which the technology has been developed, okay, starting from manual operation to semi-automatic and finally automatic. So that all we are going to discuss, how an automation application of automation in industries help to carry out, and what are its elements, so that the automation can be executed very correctly in the present industries. So before I proceed with today's session, so I will be just revising in the previous session. In the previous session, we have discussed about the reasons for automation, why we require to use the automation technology in the present industries, and what are the principles and strategies of automation, means what principles can make the manual firm or a manual factory into an automated factory step by step. That is what again we have discussed in detail in connection with the automation migration strategy. So all the three concepts we have discussed in detail, in depth in the previous session. So today I will be discussing in connection with the definition of automation. So as we are going to see on a screen, automation describes a wide range of technologies, okay, that reduce the human intervention in processes. Because any process, if at all we want to carry out very correctly, without any hampering, without any deficiency, then what we do, we make the operator involvement less, so that we are going to see that maximum process or maximum manufacturing process, okay, maximum flow of product by using what automatic material handling technology is also there, okay, where the human intervention, means human involvement, is very very less, or even it can be zero also. Human intervention is reduced by predetermined decision criteria, sub-process relationships and related actions, and embodying those predeterminations in machines. So it is necessary to know first how much involvement of a human operator is required, and what are the processes that are being carried out, what is the flow of the product. All these things is clearly carried out by the process planning department, and according to that the process takes place. So for this, the main objective is to see that the human intervention is very very less. That is why we can define in this way also now. And automation can be defined as a technology by virtue of which all the processes of the manufacturing system, whatever the process is there in a manufacturing firm or a system, are performed by machines. Totally they are performed by the machines itself, without the direct involvement of human worker. The human worker is not directly involving. He is involved, but he is involved indirectly. That is, indirectly means what? As all the machines are automatic one, we require to prepare the program of instructions that has to be stored. Only the tool settings will be done, okay, and the program settings related to a particular job is done on a machine itself, and that itself is the work of an human operator. So that is why we can say that in a manufacturing system where automation is used, okay, there is no direct involvement of the human worker. This is very very important. Automation includes the use of various control systems. This is very very important. We require to use control systems, then only it is possible to make the system automated for operating the equipment. So we require to control the equipments by using the PLCs, okay, programmable logic controllers, or by using microcontrollers, okay, such as machinery, processes in factories, boilers, just he has taken different examples, and heat treating ovens, switching on telephone network, steering and stabilization of the ships, aircraft and other applications and vehicles with reduced human intervention. So in all these processes or the production areas, the human involvement is very, very less. Means very almost it is coming to a nil, where to some extent only to observe the operation the human operators will be used in the factories, in automated firms. Okay, so now let us have an understanding about what is the meaning of an automated system. We are describing now in detail now what is an automated system. An automated system is the one in which a process is performed by machine without the direct participation of human worker. The same one which I have previously informed, there is no direct participation of human operator or a human worker. He is indirectly contributing to the process or manufacturing, because maximum involvement is there by the automatic machine itself. Automation is implemented by a program of instructions. This is very, very important, because when we are going to use automatic machines, we require to prepare the program of instructions as per the process, as per the job, as per the machine specifications, etc. Okay, instructions combined with a control system. So that program of instructions will be stored as a data, okay, in the control system, which is going to execute the instructions, means which is going to see that operation is being carried out automatically by the cutting tools or by the machine itself. Power is required to drive the process and to operate the program and control the system. This is a very common thing. Without electric power, there is no question of any production. As we know, if at all we want to drive any motor or a gearbox or whatever is there, then we require to use a power, okay, to operate the program and to control the whole system or the process or the machine itself. So there are two types of automated systems actually. One is called as what? Semi-automated system, and the second one is fully automated system. Okay. To some extent in semi-automated system, what happens? There is some human involvement is there. Semi-automated system is the one in which machine performs a portion of work cycle under some form of program control, and a human worker tends to the machine for the remainder of the cycles by loading and unloading it or performing some other task of each cycle. This is very, very important. In semi-automated system, the worker or the operator has to load the raw material and he has to take out the finished component, or he has to observe how the process is also going on at each and every step. And if some of the operations used to be carried out manually, to some extent it may be 5%, 10% he has to do it. So that is why it is called as a semi-automated system. In a fully automated system is the one in which machine performs every process of work cycle without any human worker intervention in each cycle. So every cycle means what? Every operation here, okay, or for every job, because basically CNC machines are designed to perform mass production of identical jobs as long as there is no change in the design of the product to be produced. So a fully automated system is one in which machine performs every process of work cycle without any human worker intervention in each cycle. Means at each cycle of a fully automated system, there is no need for the operator to be there. Instead, the worker may need to tend the machine every 10th cycle or every 100th cycle. Means all the operations are just he is observing. That is the only idea here. For example, in many injection molding plants, injection molding plants means where the molding operation is being carried out as a part of a casting, okay, where the molding machines run on automatic cycles, but periodically the molded parts at the machine must be collected by a worker. See what happens in an automated injection molding plants, okay, the cast that is being produced in a particular type of mold is the collection is done by the operator, but every operation is done automatically by that particular machine, okay, but periodically molded parts at the machine must be collected by a worker. In certain fully automated system, one or more workers are required to be present to continuously monitor the operation. See, in certain fully automated system, he is telling, not in all. Okay, to some extent he has to be present so as to observe the process and to make sure that it performs according to the intended specifications. This is very, very important. So here the main function of an operator is to observe the process. He is not directly involving into the production. So that is why he is observing and he is continuously monitoring the process. That's all. So that is called as what? A fully automated system. So now, as I have discussed now, so power is a main requirement for any automation system or any driving process. If at all we want to run a simple motor, we require to have an electric power. So that is what we are discussing. So on the screen, as you are going to see, we are going to discuss how is the flow chart of an automated system, how actually the automated system works, okay, and what are its elements. So the first element which you are going to see here is power to accomplish the process and to operate the system. For any machine or any driving system to work, we require to have an electric power. So that is why power is the first basic requirement. So power to accomplish the process and to operate the system. The whole process is being carried out if at all the power is present. The same power is also applicable, as you are going to see. The same power has gone to program of instructions. The same power has to go to the control system, and the same power is used for carrying out the process, means machining. So second step is instructions program. The first one is we require to have a power. Without that we cannot proceed with the operation or the process to be carried out. And the second important requirement is program of instructions, okay, to direct the process. And the third one is a control system to actuate the instruction. This is very, very important. If at all everything is there, but if this is not present, then the process cannot be carried out. So the control system, as we have discussed many a times, in case of your mechatronics subject, it is considered as the brain or heart of a control system. Okay, that is very, very important. Whatever the decision making is there, it is done purely by the control system itself. So now let us understand in detail here. As you are going to see, just I have told, the power is to be given to the program of instructions. We cannot work without that. And control system is also operated by using a power. Simply the process also is carried out by using the power itself. Okay, now let us go in detail now. The power source. An automated system is used to operate some process, and power is required to drive the process as well as controls. This is very, very important. An automated system is used to operate some process. So whatever the process is there, manufacturing process is there, okay, that process is carried out by using the power source only, as well as to control the whole system or the process. There are many sources of power available, but the most commonly used power is electricity. This is a very known fact. Of course, there are various power. For example, we consider hydraulic power, but okay, or pneumatic power or thermal power, whatever is there. So generally, what is the concept here? We require to use the electricity as a power in automated system. The actions performed by the automated systems are generally of two types. So what action is performed by the automated system? The first one is a processing, and the second one is a transfer and positioning. The processing means what? The operation to be carried out at different levels. This is the first step. And the second one is transferring the workpiece or continuation of the process. And positioning means to see that the job is made to flow correctly with the help of the automated material handling system. So in the first case, the energy is applied to accomplish some processing operation on some entity. Okay, the process may involve shaping, molding, or loading and unloading. That means processing means what? Any operation, just I have told, it may be a shaping, it may be a molding or loading and unloading also. All these actions need power to transfer the entity from one state or condition into more valuable state or condition. That is the requirement. The second type of actions, transfer and positioning. In these cases, the product must generally be moved from one location to another during the series of processing steps. Just I have told, if at all we want to see that, we have installed various automatic machines by using a particular type of layout, then there should be a perfect flow of a job or the workpiece from one workstation to the another automatically. This is what the transfer and positioning part is going to play. And if at all these two have to happen, that means the processing has to take place, the transferring and positioning has to take place. That is possible if at all we are going to use the power source or electricity. This is the first requirement of an automated system. And the second requirement is program of instructions. So just I have told, it is here the major role is played by an expert programmer who is going to study the entire process or the job to be produced, and according to that only he has to prepare everything in connection with the preparation of the program instructions, and that has to be stored in the machine, automatic machine, as a control program. The actions performed by an automated process are defined by a set of instructions known as process. Definitely, whatever the action that is taken by the machine or by the firm, by a company, that itself is nothing but what? Automated process. The programmed instructions determine the set of action that is to be done automatically by the system. This is very, very important. So as per the programming instructions, what is written, according to that only the process will be taking place. The program specifies what automated system should do and how its various components must function in order to accomplish the desired results. To give a simple example, if at all I want to produce a simple turning job having different operations like rough finishing, fine finishing, drilling, reaming or tapping, etc. So all these things have to be carried out in a sequence. So as per that only the program instructions will be written and stored in the control unit of a machine. So when the machine is made on, automatically these operations will be taking place in a sequence. So this is how the system works. Okay, whether the manufacturing operations involves low, medium or high production, each part or product cycle made in the operations requires one or more processing steps that are unique to the cycle. See, this is very important, whether the firm is concentrating on low quantity production while describing about the different types of productions like low quantity, medium quantity and high quantity. So depending upon that, okay, one or more processing steps are required to be carried out, and according to that only the process takes place. These processing steps are performed during a work cycle. Okay, a new part is completed during each work cycle. In some manufacturing operations, more than one part is produced during one cycle. That is, example, a plastic injection molding operation may produce multiple parts each cycle using a multiple cavity mold. There may be multiple cavity mold may be there. Number of jobs can be more in that case. The particular processing steps for the work cycle are specified in a work cycle program. So they are going to prepare one work cycle program. Means what? So many a program of instructions can complete so many cycles of work, means operations to be carried out. Work cycle programs are called as part programs in numerical control. Other process control applications use different names for this type of program. So this is very, very important to understand here, that we require to prepare the program of instructions. They are also called as part programs. Part means job. Which type of job we want to produce and how many numbers. Okay, so based on that, the program of instructions is stored in the control unit and the process is carried out by the machine itself. This is very, very important. Now, what is the meaning of work cycle programs? In the simplest automated processes, the work cycle consists of essentially one step, which is to maintain a single process parameter at a defined level. Example, maintain the temperature of furnace at a designated value for the duration of a heat treatment cycle. So what is the meaning of that? One heat treatment furnace is there. In that particular, we want to maintain that temperature. In this case, the programming simply involves sensing the temperature dial on the surface. To change the program, operator simply changes the temperature setting. Very simple thing is there. One heating furnace is there, which is set at a particular temperature. So if there is any change in the temperature, the operator has to only change the setting temperature. The furnace is going to work automatically as per the program of instruction only. Only by, if at all any change is required, the main function of an operator is to change the setting level of that particular temperature. An extension of this simple case is when the single step process is defined by more than one process parameter. Example, a furnace in which both temperature and atmosphere are controlled. So this we have taken an example as a one work cycle program. Means what? One cycle of program. We want to control the furnace which is heated, which is previously set as per the programming of instructions, particular temperature. We want to change the temperature of the furnace. This can be done at ease by the operator by changing the dial indicator which is outside. Okay, so that the temperature can be controlled. But if more than one parameter, okay, that means what? We want to control the temperature as well as atmosphere. Okay, that also is there. In more complicated systems, the process involves a work cycle consisting of multiple steps that are repeated with no deviation from one cycle to the next. Most discrete part manufacturing operations are in this category. So what is the typical sequence? Load the part into the production machine. The first step is to loading the part to the machine, in first machine, second machine, whatever the machine's layout is there, according to that. Perform the process in that machine, unload the part. Then it is going to the next machine, like that. During each step, there are one or more activities that involve changes in one or more process parameters. What is process parameters? Are inputs to the process, such as temperature setting of a furnace, just we have taken. Coordinate axis value in a positioning system, valve opened or closed in a fluid system, motor on or off. This is all called as process parameters. Process parameters are distinguished from process variables, okay, which are outputs from the process. So because as per the process parameters, there is a variation in the output side also. For example, the actual temperature of the furnace, the actual position of the axis, the actual flow rate of the fluid in a pipe, and the rotational speed of the motor. So all these things are considered as the output side. So process parameters are decided by the process planning department according to the process being carried out, and it is possible to see that the work cycle process is carried out by using a correct way of program of instructions. So this is the most important, because if the program of instructions is wrong, then we cannot proceed. We can't proceed with the operation correctly. Okay, and the third one is called as the control system. See, the control system, as I have told, it is also considered as the brain or heart of a entire machine itself, automatic machine itself, because whatever the program of instructions are there, that is only read by this control system, and purely the action is taken as per the program of instructions. So if program of instructions is wrong, the control system works in a different way. So that is why the program of the storing of programming, the program of instructions plays a vital role in all types of automated industries. The control element of the automated system executes the program of instructions. Okay, the main execution means what? Carrying out, reading and taking actions. The control system causes the process to accomplish its defined function. That is what I am telling. As per that, we start taking the actions. The controls in an automated system can be either closed loop or open loop. This is very, very important. See, what is going to happen here is either it can be a closed loop system, which we have discussed in the mechatronics subject also. When we take the particular parameter from the sensor, then you are going to have the error rectification. That error rectified will be sent to the manipulator, then again it will be going for the control system, then the control system will take some action, then finally the process or the output takes place in a simple way. But if at all the output is fed back to the control unit to check whether the output is correct or not, then it is called as a closed loop system, or also it is called as a feedback control system. Okay, the controls in an automated system can be either closed loop or open loop. A closed loop is also known as a feedback control system, in which the output variable is compared with the input parameter, and any difference between the two is used to drive the output into agreement with the input. Whatever the input is put, okay, if according to that whether the output is coming correctly or not is verified, then if any error is there, that can be rectified. So now as you are going to see very clearly, okay, in the figure, this is called as a closed loop control system. This is as good as a revision which you have already learnt in the mechatronics subject. So the first one part is a input parameter, second one is called as a process, third one is called as the output variable, and the fourth element in the system is called as a feedback sensor, and the fifth one is called as a controller, and sixth one is actuator. Actuator means what? One which is not shown and where the actual function takes place, okay, as an output variable. Now let us have an understanding about these things. A sensor is used to measure the output variable and close the loop between the input and output. Very simple thing is there. The main function of the sensor is to sense, and it has to close. It is going to act like a closure between the input and output. Sensor perform the feedback function in a closed loop control system. The controller compares the output with the input and makes the required adjustment in the process to reduce the difference between them. Whatever the difference is there, that difference is carried out, because here the input parameter is there, controller is there, actuator is there, which is going to be carried out. If the process is there, that is sent back. Feedback is there. If any error is there, that has to be rectified by the controller itself to carry out the further processing for accuracy. So in contrast to the closed loop, suppose in a closed loop what happens? We require to take the feedback, okay, but here in contrast means opposite to this, it is called as an open loop control system, operates without the feedback. Okay, so here what we are going to do in this case, the control operates without a measuring output variable, so that no comparison is made between the actual value of the input and the desired input parameter. Whatever the value of output we want, actual and the desired input, both are not compared here. So that is why open loop control system is often called as a inaccurate control system. The controller relies on an accurate model of the effect of its actuator. With an open loop system, there is always the risk of that the actuator will not have the intended effect on the process, and that is the disadvantage of an open loop system. So what is the disadvantage? We don't know whether whatever the output we are getting is correct or not. That is due to non-feedback system. We are not taking the output back to the controller to check whether the output is correct or not. Its advantage is that it is generally simpler and less expensive than a closed loop system. The only advantage is what? It is not a complicated process, the open loop, and definitely it is less expensive also. So as you are going to see the figure, it is very clear. The first input parameter is given here as usual. Okay, controller takes some action, actuator functions, process takes place, then the output is there. So what is going to happen here is there is no feedback, as you are going to see very clearly from the output variable. Okay, the open loop systems are usually appropriate when the following conditions apply. When we are going to use, that is also an important point to be noticed here. The actions performed by the control system are simple. Whatever the actions are there, they are very simple. Then we can go for the open loop system. In that condition only we can use it. If at all any complicated process is to be controlled, then we cannot use the open loop control system. The actuating function is very reliable, means your actuator is very perfect. is going to work in a correct way. In that condition only you can go for the what? The actuator may be a motor, may be a valve which is made to open and close, whatever is there, or maybe a solenoid, like that, solenoid valve. So all these are called as actuator. If they are functioning correctly, then we can say that we can go for the open loop control system. Any reaction forces opposing the actuation are small enough to have no effect on the actuation. If these characteristics are not applicable, then a closed loop control system may be more appropriate. That means if at all we want more accuracy, then we have to go for a closed loop control system, though it is costly, expensive and complex compared to what? The open loop control system. In order to conclude, the main function of the control system is to see that the correct output is being taken into consideration to carry out, to execute the operations correctly. So that is why almost we have completed the three important elements of an automated system. We started with the electric power, then what is the role of a program of instructions, and what is the function of a control system. So in examinations, either you can write about the control system like open loop or closed loop with a sketch, depending upon the number of marks. So now let us start with the very, very important, and that is today's last concept, and we are going to finish off today the chapter number 1, that is CO1 will be completed today itself. In the meantime, I am also going to put the important questions like remembering, understanding, applications questions as given in the syllabus. So every student has to prepare answers for these questions, as we have already put. You go through the syllabus, okay? In that we have already put our PPTs or PDFs or photos, images. Just note down all the notes from there and write the answers for the questions which I am going to put in a WhatsApp group. Okay, so now let us start with the last concept, that is levels of automation. Now when one thing we know that one thing is very clear, that whenever we want to consider or whenever we want to move from manual operation system to a semi-operated system to an fully automated system. So these are the three steps here. The first step is manually operated system. The second step is semi-automated system, and the last one is the most important phase, is the fully automated system. So now we are describing about the fully automated system. So whenever we are going to adopt this fully automated system, so where it starts and where it ends, what is the starting point of that, where the automation is applied, and which is the highest level. There is one is called as the lowest level and another one is called as the highest level. So what is the lowest level of an automation and what is the highest level of an automation system, that we are describing now in the following steps. Okay, that means in any industrial operation, if at all automation technology is used in any process, in any plant, production plant, then they have to adopt the following 5 levels of automation, as you are going to see on the screen there. The first one is called as a device level. The first level is the device level. Second one is called as a machine level. Third one is called as a cell or system level. Fourth one is called as a plant level, and the fifth one is called as an enterprise level. So as you are going to see very clearly, device level is considered as the lowest level of the automation system. Try to understand. Device level is the lowest level of the automation system, whereas enterprise level is the highest level of the automation system, and cell or system level is going to stand as a midway. It is neither device level nor enterprise level. Okay, it is going to stand as a midway from the device level to the enterprise level. So as you are going to see clearly on the screen. So let us start with the device level. What is the meaning of a device level? What is the meaning of a device level? This is the lowest level in automation hierarchy. Automation hierarchy means step by step how the automation technology is applied. It includes the actuators. Basically, when we are going to speak that we have an automated device. If I say that I'm having an automated device, so what an automated device includes, it is having actuators, it is having sensors and other hardware components that comprise the machine level. So all these device means we require to use the sensors in all the different devices of a machine. Then only it is possible to go for the next level, that is called as a machine level. If at all I want to go for any automatic machine, first of all I have to make the devices as automatic, means using certain sensors. The devices are combined into individual control loops of the machine. For example, the feedback control loop for one axis of a CNC machine or one point joint of an industrial robo. If at all I want to see that, and we want to go for a building of an industrial robo, so one of the joints is there which is used for picking up, loading or unloading of any job is there. So if at all it has to happen, then that industrial robo joint has to be automated. How it is automated? It is as good as one of the devices of the entire robo. So that device is having certain sensor which can do all this function. So that is why it is going to start with the device level. Okay, and it is also called as the lowest level of automation system. The next one is a machine level. Hardware at the device level is assembled into individual machines. Okay, all these device levels means what? All these devices which are having sensors, okay, which are having actuator, all these are assembled and they are going to use as a part of a machine itself. Okay, CNC machine tools and similar production equipment, industrial robots and powered conveyor, these are the examples of machines which are there. Control functions at this level include performing the sequence of steps in the program of instructions in the correct order and making sure that each step is properly executed. As I have told, the control functions at this level, whatever the controlling action is there, that is purely carried out in the machine itself. The machine level is nothing but the automated CNC machine itself, okay, which is going to have different devices, okay, and assembled as one machine. Remember, okay, cell or system level. The next one coming is cell or system level. This is the manufacturing cell or system level which operates under instructions from the plant level. Okay, so as you are going to see very clearly here, you require to understand that there is a continuous flow from device level to the machine level, from machine level to the cell level to the plant level to the enterprise level. Again it comes back. Okay, that again we are describing in the next slide how there is a flow of information is there. Okay, so as to control the entire process correctly. The manufacturing cell or a system is group of machines. So what is the meaning of a cell or system level that we are describing? Here in a manufacturing cell or a system is a group of machines or workstations connected and supported by a material handling system. So that means cell or system level consists of different types of automatic machines. Remember, in a correct layout where the automatic material handling system is used. That is why it is called as a cell. Cell means what? A number of machines arranged in a systematic way. It is called as a cell. Okay, workstations, automatic workstations, and supported by a material handling system, computer and other equipment appropriate to the manufacturing process. So as per the manufacturing operation to be carried out, they are integrated, joined together and automatically operated. Production lines are included in this level. All production lines means flowing from one station to another. Everything is done automatic. Functions include part dispatching and machine loading, coordination among machines, material handling system, and collecting and evaluating inspection data. Cell or system level includes all these things. So it is going to be considered as a dispatching, machine loading, coordination among machines, means perfect working among the machines, and with a correct material handling system, collecting and evaluating inspection data. So collection of the inspection of the job being produced and taking the necessary action. Everything is done at the cell or system level itself. Okay, that is what you are going to see on a screen here. Okay, we are going to start with the device level, which is the lowest level, and enterprise level is the highest level. Cell or system level is called as a midway. Okay, that is very, very important. So the next one coming up is called as a plant level. It is a factory or a production systems level. It receives information from the corporate information system and translates them into operational plans for production. Its functions include order processing. In plant level means what? The entire plant is made to run. So it includes order processing. What type of job we want to produce, that has to be decided. Process planning department is coming under plant level. Inventory control, how to procure the raw materials, where to keep, how to keep, okay, how to make the system work, purchasing of the raw materials, material requirements planning. It's also called as MRP. Okay, and shop floor control and quality control, all this is coming under the plant level controlling system. Okay, and the last one is called as a enterprise level. So it is concerned to the management of the entire plant itself. That is why it is considered as the corporate information system. Okay, so this is the highest level consisting of corporate information system. It is concerned with all of the functions necessary to manage the company. Whatever the function of the entire plant is there is purely guided by at the enterprise level only. It is concerned with all of the functions necessary to manage the company. If the company is managing means what? It is through the enterprise level. Okay, like marketing and sales, accounting, design, research, aggregate planning, and master production scheduling. So all these things are coming under what? Enterprise level. So enterprise level is the highest level, device level is the lowest level, and cell or system level is the midway level in case of levels of automation. Okay, so that completes the today's session. Okay, and one more information I wanted to tell you, because as you are going to see here again, they have extended the lockdown period up to June first week, as you know very well, and already most of our staff members have started with the 6th semester portion, as you are going to listen to the videos, and at the same time you require to answer the assessment questions for each of the sessions. This is one point. And the second point is, already we have put, okay, your name of the student along with your phone numbers and along with the student code, and this is only to give you an idea, see what is the status at present from your side to know. That means because as we have already started with the 6th semester portion, okay, you tell your parents to pay the fees. Already we have put the IFSC code, account number, so it is better if they pay the fees through Google Pay, Phone Pay or NEFT, as it is not possible to come physically to the college and pay the tuition fees. So it is also instruction from the higher authorities, because already we have started, as good as though we have not started physically the college, we have already started with the portion, and most of our staff members have completed the chapter number 1. So that is why it is necessary to tell your parents, okay, to see that they are going to pay the fees. So for that also the staff will be calling you to the parents or to you also to get the information about the tuition fees, and you require to give the correct information in connection with the same. Okay, with this I conclude the today's session. Thank you.
Hello friends, this is Shri Krishna Joshi. I'm working as an associate professor in the Department of Mechanical Engineering, Indian Institute of Technology, Guwahati. Welcome to the course on automation in manufacturing. Well, my friends, the manufacturing term has various definitions, but in general, we can simply say manufacturing is nothing but the conversion process in which we are converting raw materials, semi-finished goods, into a finished goods by using either human beings or the machineries. So when we talk about production of goods or products at mass scale, at larger production volume, then naturally we have to take help of the machinery or the technology. So for that purpose, we need to automate the process. So this is the content of this particular course. Well, the manufacturing sector in general contributes a major share in the gross domestic product of a country. In India, it is around 15 to 16% now this year, and the government of India is planning to, or they are aiming to enhance up to 25% by 2022. Well, to enhance the productivity or to achieve this target of 25% and without losing the product quality, to have the desired product quality, it is essential to automate the manufacturing process, as I mentioned you. But how it is possible? So to make it possible, we need skilled technocrats and engineers which are having the fundamental knowledge of the automation in manufacturing. And these skilled technocrats and engineers will also have the capability to design and develop such systems which will helpful to the manufacturing sector. So in view of this particular course has been designed and developed. The primary objective of this particular course is to impart the knowledge, the fundamental knowledge of various automation types used in the manufacturing, various products, automated systems which are commonly being used right now, such as CNC machines, industrial robots in manufacturing sector. And the second objective of this course is to develop actually such systems. So to develop such systems, we must know what are the building blocks of these automated systems. So with these two objectives, the syllabus is comprehensively designed. It covers all these aspects of design and fabrication of an automated system. What are the various building blocks, or what are the various aspects of the automated system? So these are the sensor technologies, actuation technologies, signal conditioning methods and devices, the microprocessor technology, various electrical drives, various mechanisms which are essential to develop such automated system. The syllabus also has two modules on the pneumatic and hydraulic systems, and we will be also having a few lectures on the CNC technologies as well. The syllabus also has various industrial case studies and real life examples. The unique thing about this course is that this will make you capable in designing and fabrication of mechatronics based automated system which can be applicable in the manufacturing sector in particular. So you can use mechatronics based systems for various other applications as well, but the focus of this course would be more on the manufacturing sector. Well, this entire syllabus has 12 modules and it has 30 lectures. This course would be useful to the undergraduate and postgraduate students of mechanical engineering, production engineering, industrial engineering, mechatronics engineering. It will also be very much useful to the practicing engineers, those who want to hone their skills in this area. They are having enough practical experience in the industry. However, they can brush up their knowledge theoretically by taking this particular course. To have more effective learning through this particular course, the students should have basic knowledge of electronics engineering and electrical engineering, which will be essential as the course content is designed. So with this, I thank you for listening to this introduction lecture. I must say